Hello, everyone. Very good evening or good morning based on whichever time zone you are joining in from. Today, we will be introducing a new learning session. For a couple of weeks, we are going to be talking about Kubernetes and some of the basics and some of the advanced concepts of bringing up your applications and deploying them on Kubernetes. And we have curated this content based on our experience for the last few years in building a Kubernetes based platform. So we have tried our best to keep the concepts and the process as simple as we could. Right. So let's get started with the session. So today is the week one, and it's actually an 8-week session. I'll be running you through the structure of the session and what we will be covering in each of these weeks as we move along. Right. So Cube for All is, as I said, it's the learning session that is aiming to make the learning process as simple as we can. If you are liking the session or during the session, if you want to share any of your ideas, please use these hashtags Cube for All or KATS for All. And if you really want to appreciate the contents, and if you want to kind of motivate our team to do and to share more such contents in the future, please do tag us using at gopaddle.io. Right, let's get started with the session. So the instructors for the session would be me, who would be mostly, I'll be introducing some of the concepts, and I come with development experience, and I have architected platforms, and I'm an entrepreneur. Most of you might know me over social media. So I'm the founder at gopaddle.io, which is a no-code platform for Kubernetes deployments. We've been building this platform for close to 4 to 5 years now, and I have actually played the role of a developer. I have written code, I have architected the platform, and I have spoken to a lot of customers and understood their use cases as well. So most part of it, like, I'll be introducing the concepts, and I'll be joined by my team member Gayatri. Gayatri, do you want to introduce yourself? Okay, looks like we've been having some issues with the audio. Let me quickly check. I think you are on mute, Gayatri. Would you like to unmute and introduce yourself?
No, I think I mean, uh, just 1 second. I'll check.
If we are able to hear you, Gayatri.
Okay. Yeah. Hi, guys. Actually, I'm a front-end developer at GoPaddle, as well as I'm a blogger and passionate learning Kubernetes and the related technologies. And also, I have been doing like product evangelization in various mediums. Like, yeah. So,
Okay, so looks like she's breaking. So basically, she has been a part of the KCD Chennai organizing team, and she has helped build this platform with us, and she has been evangelizing a lot about Kubernetes and DevOps. Let me move on, and excuse me, yeah, let me move on. So this is the agenda for today's session. So first, let me introduce you to some of the expectations that we have when we get started as a as a Kubernetes developer or a DevOps engineer or an SRE, right? And what is that we expect at the end of this project versus what we see in reality, right? And what is the process that we take in this whole process of automating and deploying to Kubernetes? And why do we find it so hard to do this? And what challenges do we face? And how do we anticipate these challenges and make sure that we do things the right way, right from the beginning? And what are some of the best practices that we could share and take you to the path of innovation? And innovation can happen once we have the efficiency and the right controls in place. All right, so this is the foundation for us to understand this whole landscape before we get into the course contents and how we are going to structure this whole course for you. Right. So we want to make this more interactive and make it really useful to you. So at the end of the session, what is that you can expect? Say at the end of the 8th week, what is that you could expect out of this session? Is what we are going to cover overall in today's session. So it's mostly an introductory session today. If you have any questions, please feel free to post it in the the chat room, and we will be able to help you with the right pointers, or we can also give you some information. Okay, so when we start the Kubernetes projects, our expectation is that we want to consolidate the infrastructure. So we may be running on cloud. In some cases, it may be in a data center on a set of servers. It could be a private or a public infrastructure. So the whole idea is that we want to consolidate those environments and bring it to a centralized, consolidated infrastructure so that we have better control. But in reality, what still happens is that there are certain workloads that we cannot still move to and move to and consolidate because of the nature of the applications, because of the data lock gravity that we have, that we cannot move all these workloads, and we are still stuck with the hybrid environment, and we still have multiple environments for different stages of their life cycle. So even though we wanted to consolidate, there are still different environments that we have to manage. And we intend to optimize the cost because we consolidate. We want to have a shared infrastructure, but we still have a sudden surge because of unexpected usage of the infrastructure. All of a sudden, we see that there is a spike in the infrastructure use, and still the cost is not under control. We want to achieve efficiency and productivity because we are going to containerize and we are going to automate a lot of the process. We expect efficiency and productivity at the end of this, but we still see suboptimal deduction of issues, and the time we take to resolve those issues are longer. So the productivity still comes down because of the difficulty of the whole setup, and because of the distributed nature of the applications. It's still a complex environment to debug and resolve issues. So the whole goal is make the whole development process or the engineering process faster, release more frequently, but still we have some missed deadlines. So I'm talking this out of my own or our own practical experience of implementing this deployments on Kubernetes over the last 2 to 3 years. So our own production environments run on Google Cloud infrastructure, and some of the workloads on AWS, DigitalOcean, and various such hybrid environments. And our whole engineering process is based on Kubernetes, and we are automating, and we are still automating, right? So we know, like, we wanted to achieve these goals, and in reality we faced all these challenges, these bottlenecks at every phase, and we had to kind of overcome those, right? So in the session, my goal is to introduce you to these realities, and then share some best practices, and set some stage for what are the challenges that you can anticipate and overcome right from day one, right? And keeping that in mind, we will introduce you to how to speed track this whole thing. So let's talk about the process, right? So typically, in based on the nature of the organization, based on the nature of the application, we may start with a monolithic application, and then we do a modernization process in order to do an architectural transformation, right? You start with a monolith application, you convert it into a microservice, and usually, yeah, organizations follow a 7R strategy on deciding whether the application has to be re-architected or refactored, or we have to throw away that code and then buy a new one, or we have to retain the whole application as is. It's so built that we cannot really refactor or even re-architect, right? So in such cases, it's mostly those monolith applications remain. In some cases, it is thrown away. In some cases, a software is bought with the same set of capabilities, or some parts of the application gets re-architected, and it is tied to Say, for example, if it is a traditional database, a relational database, then a replatforming may actually move to a more like a distributed database, right? Rehosting is you kind of take the whole application and package it as a Docker container and then deploy it on a Kubernetes environment. Right? So all of these strategies depend on the business priorities and the nature of the application. But once we have the microservice, once it is ready for containerization, right, then we actually go through a containerization process where we have to start looking into different categories of information and start building the Docker images, right? So we are going to focus on, in this whole session, we are going to focus on how do we start with containerization until we reach the efficient or the automation that we need in place, right? So the modernization itself is a huge topic by itself. We will not be able to cover that topic, but as a platform team, we are more than happy to share some information offline on how this can be done, or maybe in subsequent posts we can share some additional information on that. But for the whole session, the learning session as such, we will be focusing on containerization, Kubefication, and the automation. Right. So we are going to take you through this whole process and make sure that at the end of the session you get the entire setup at a small scale, right? So when we start talking about containerization, we are going to build the Docker files, we are going to build the Docker images, right? We know the benefits of doing that, so I'm not going to talk about it, but I'm going to talk about the process here, right? So we need to understand the application before we start containerizing it. So what are the different attributes that we need to know in order to containerize, right? So we have to understand how to build the application, how to run it, how to restart it, and how to check for the availability of that service, right? These are four fundamental configurations that we need to know for any application before we start containerizing it. So when we say build, so for example, if we take Java, so we probably may be using a Spring Boot application, or it could just be a Maven build, right? Or an Ant build, or it can be a Gradle, right? So it based on whatever way it's already been built, right? So we need to know how to build that application, right? And once we build that, how do we run it, right? In most cases, if you see, if it is a Spring Boot, it is when we just do Maven build or Maven run, right? So usually it is split, but in some cases it is just a build and run, or in a single phase. But we may have to split that into a build and a run phase, right? And then we need to know how to restart the application. Now, most often we miss this step. Yeah, most often we do not think about stopping the service. We usually do a control C, and as a from a development environment, we just do a sick term, kill the process. But in some cases, and this happens most often in a Node.js based application, right? If a Node.js application runs, it can actually spawn sub processes, right? And if we do a sick term, usually it's the parent process that gets killed, and then all the child process still remains, and that's not the best practice, right? So when you are running inside a container, you need to make sure that when you are stopping something, all the sub processes also stop when you do a sick turn. So you need to know how to gracefully exit, right? So we need to have some scripts that will gracefully exit the service. And the last one would be to know whether your service is up and running. So it's usually the health check, and this is mandatory if you are deploying to production. So you need to know how to monitor the health of a service, whether it is up and running, right? We need to monitor because we are looking at high availability. So if it is coming down, if the service comes down, we need to know that it has stopped, right? So we need to create these health check scripts. So these are four fundamental scripts that we can prepare and keep it handy before we start doing the containerization, right? Next comes the dependencies. Now this is a huge topic again by itself, because most often, right, bottlenecks happen here, right? How do we identify if the service is very much tied to an IP address? So it's a VM based or a host machine based deployment. If there are IP dependencies, then we have to start working with our other colleagues and in IT teams to make sure that some of those discoveries and dependencies happen based on names, because the moment we start looking at deploying to Kubernetes, it's all based on service names. Or we have to, if it is an external service, we need to look at discovering through domain names, right? And then the dependencies, right? So if we have any libraries, Node.js libraries or Java libraries that we have dependency on, we need to make a list of all those dependencies before we start containerizing. And why is it important? Because we can then, once we have a list of all those dependencies, we can start preparing what is called as a base image, which will be more or less standard across your application updates, right? You don't have to keep building those base images every time you make a change in your application. So you need to kind of layer these libraries and prepare a base image so that you keep those libraries standard, and then start building your application on top of it, right? So your when you want to kind of do a continuous integration, it becomes a lightweight process. You don't have to download, install all those libraries every single time you make a code change. So it's very important that you efficiently manage these dependencies. Next comes the reusable and persistent data. So here you have to look at the configurations or the data that you store as an application. Now you can look at if you are not using your databases, right? But you still persist some information within your container. Then if you want to reuse it across restarts, the best approach would be to keep it as a volume. So you need to know, segregate and keep those information or configuration separately, so you know where to use volumes, right? And where to use databases, and where to use just the local container storage itself. So the container storage is as and when you restart it, all your data is lost. Env specific and reconfigurable configs. This again is very important. Like if you want to take the same container and then use it across different environments, so you need to pass those environment specific information in the form of envs and reconfigurable configs. So we will talk about it more. I'll run you through the challenges if you would face if you don't handle these configs in the right way. But you need to kind of make a list of all those envs and configs. And the next one is about the capacity. So what is the optimal capacity? As a developer, we know what is the optimal capacity for running this application, what would be the peak capacity that it might consume, right? And we can suggest or even share this with the DevOps teams, so that they can provision and plan for the capacity at the infrastructure level. But as a developer, I think developers are the right people to suggest what is the ideal capacity for their applications, both at a nominal usage as well as at the peak loads. Next comes so at the end of this, we have a container. I mean, we prepare the Docker files, we prepare the base images, we have the container images built. Next comes the deployments. Now here is the kubefication process, where we start provisioning the Kubernetes environments, which again is a huge topic by itself. We will, for the time being, we are going to take a pre-existing environment, and then throughout the session we are going to use a very lightweight environment. But we will have subsequent sessions like Kubefication in the future learning sessions on how to provision clusters in a more production grade scalable environment. But for the time being, we are going to focus on a minimal infrastructure like microcadus, and then see how we can containerize and move your applications to the Kubernetes environment. So what comes at this stage is to map these containerized parameters, and then map them to the kube specific deployments. For instance, we are looking at health check scripts here, which have to map to the health check parameters in kube. Similarly, the configs map to config maps, and so on and so forth. So this is again at a basic level. It is straightforward to create all these YAMLs, but for a production grade deployments with multiple configuration, things can get difficult. So I'm going to talk about it in the next slide. All right. Once we have the deployment, next comes the automation. Again, this is big task by itself. So we have a lot of these third party tools and configurations that we have to start integrating and adding monitoring, alerting, logging in order to make sure the last phase, which is the maintenance, becomes easier, right? And also, tie that to the application development lifecycle and the release automation. So we have to put a pipeline in place, right? So this, even after it's all done and automated, when it comes to the release management and the maintenance, we may still face issues, and we have to go back again and start from the containerization and see whether it's all done fine. And we have to again implement a few changes, again do some changes to your deployments, the way you deploy, and again improve upon the automation. Now, this is the room. So the day one is always, looks straightforward, right? But the moment we step into day two, again the challenges come in. You deploy to production and you see some challenges, again you come back to the containerization. So this is an iterative process, and this is the window for efficiency. So if we don't do it, anticipate all these challenges and start implementing the right process right from beginning, this whole cycle can take a long time. And we have faced this challenge ourselves, and every time. So when we initially started with the deployment, so I'm going to show you the challenge. So what challenges we faced, and it may not be limited to just these, because this is our own experience of deploying to Kubernetes for the last 2 years. But it is not limited to this, and you will find a lot of articles on what challenges people face when they run their workloads in production, right? So I'm going to talk only about those that we have faced in our experience, right? So the service disruption. Now, so we happily, we deployed it on Kubernetes, and we expected that, it will be, because it is highly available, we have added all the replicas and everything, it is going to run smoothly, right? But it did not happen that way. So we our services went down, right? And we realized that we had enabled auto upgrades, and automatically, Kubernetes version upgraded, and some of the services that were running, for example, the RabbitMQs and Inflex and all those, they all of a sudden they become incompatible with the new version of the Kubernetes, right? So it's better to look out for whether auto upgrades are enabled or not. And in some cases we used latest tags. So for example, MongoDB, like we just set the latest tag, and all of a sudden, the behavior became unpredictable. So never ever use latest tag in any of your Docker images. So you have to start tagging them with the right versions. And the data grows. So we have a lot of logs, we have a lot of metrics that we collect for our own self as well as for our customers, and the data keeps growing. And the disk capacity, the usage overshooted, and the node comes down, right? And all of a sudden, all the services that were running on those nodes, kind of got rescheduled. And if you have a stateful application, then it gets rescheduled to a different node, and your data is lost, and your service is gone, right? So this is another problem typically you face. Config update. So we have a lot of config maps and configurations that we maintain, and these configurations are not in sync with the Docker builds that we have. And sometimes, we have different environments, and you have to keep all those configs updated across all the environments. And if we miss out something, then your application starts misbehaving, and the service is disrupted, right? And again, like we have implemented all the best practices is what we thought, like we have all those deployment strategies in place, with all those surges and everything, but still we face downtimes during updates. And we realized, we have to test these deployment strategies ahead of time, right? Ingress and caching, right? So we have the domain name setup and everything. We use all these ingress controllers and everything, and still, there were some service disruptions a lot of times before we actually fix this. And we realized that even the ingress implementation has to be done right. Nodes can go down, and improper scheduling of the stateful sets, as I pointed out, like it can lead to data loss, right? And if you have distributed environment across different zones, the zone latencies can actually cause synchronization issues, and you can lose some data. Now, this may be overwhelming for a beginner, but the reason why I'm talking about this is while it is exciting to implement Kubernetes, but taking this to the next level and putting it in a production, like we have to start thinking about all these challenges ahead of time, which is right from your containerization itself, right? And uh, the reason I'm pointing this out is that we need to start looking at it when we are building the application, right? So for a beginner, you can skip this for the time being, but for somebody who has already played around with Kubernetes, I think you'll be able to relate this very well. Overshooting budget, right? Yes, so we've seen like, okay, we have put all the auto scaling in place, but still, all of a sudden, we see a huge bill, and the reason could be, it scales up and then it didn't scale down, and we realized that we haven't put the right level of monitoring and the right level of scale up and scale down attributes, right? So we will talk about it again in the next couple of slides. If we are working on a remote environments, we use SSH tunnels. Some of the WebSocket streams and distributed apps may not work because how we talk to other services also matters, like whether we are using proper naming conventions or the service names. Say for example, there is a concept of headless services. How do we interact with those services? All those things, how we implement those also matters. There are cloud specific limitations. If you have worked on AWS environments, you will know that there are network controllers, and even if you kind of scale down some of the network controllers, the network interfaces may not be released, and your scale up and scale down may not work as you expect, right? Similarly, improper use of tokens, and if any security token leaks, then it is a huge threat to your credibility, right? So how you handle those secrets, and how do you maintain those tokens, how do you do the token rotation, all of those matters here. Similarly, as we moved along, and like our own platform is now available across multiple distros, we have parallel releases. So in my multiple distros, in the sense, we have a SaaS version, we have an on-premise and a Lite edition. So we have different types of distributions now. Adding to this complexity, you can imagine how we have to build and release parallelly and across different environments, right? So this is hard, right? Initially, the first implementation may look simple, but when we start looking at all of this, it is definitely a hard task. And this is only from our experience I've listed. As I said, there could be even more, right? And this is where I think we would like to hear from the community to know, have you faced additional challenges, and do you have some suggestions on how you went ahead and then resolved all those? I think it will be helpful if you can share it with the community, and then help others also learn from it. So why did this happen, right? This happened because we did not have a knowledge of day two from day one, right? How we could not anticipate all of this from day one. We could have avoided most of it if we had known that these problems will happen, but we didn't know about it, or about all those, right? And second thing is, we were building this platform, but still, we didn't know what all governance that we need holistically in order to get to an end-to-end management and visibility of the whole process. Kubernetes is a huge area to learn. There are so many capabilities that the community is building, but what is that we need in order to make our own process efficient? We may not need all the capabilities. We may just need a few of those, the basic ones, right? In order to have the right governance, and in order to have the right visibility into what is happening in the system, right? And this, we realized, and we started building that, and we realized that most of these are common problems across most of the organizations, right? So let's take, how do we anticipate challenges, right? So if you are implementing containers already in your organization, so these are some of the questions that you must ask, right? Are you promoting the Docker images across EMVs, across your environments, or are you building environment specific images? Now, if you're building environment specific images, you are doing something wrong here, because it's not efficient. It is going to take additional cycles of building, and it is going to take again a lot of time from every other engineer, right? So it may be wise choice to spend a little more effort to move the environments and configs outside the container and mount these configs as volumes, right? Expose the environments at the runtime. So it may be a slight improvement that you can do, and you will see a huge difference and a time saving by doing this. Are you provisioning suboptimal instance capacity to hold your containers? So in the sense, if you are taking a large instance and you are running a small application, then there is obviously something wrong. So looks like your containers are heavy, right? You have to make them lightweight. So some of these best practices, you will find them online, and I can suggest this maybe towards the end of the session. So I have gathered this from a really good websites, and we also implement a couple of these ourselves. For instance, you need to have a Docker ignore file. So when you're building your application, you don't have to build everything that is there in your repo. For instance, if you have a Node.js application, you have your Node modules folder. You don't have to package all the Node modules into your Docker image, right? You just need your binary that runs your distribution that runs your service. So you can add your Docker ignore, right? If you're maintaining some keys, some tokens, you definitely need to include Docker ignore to ignore those sensitive information. You need to have multi-stage builds. For those who are not familiar with multi-stage builds, it's basically, you have to segregate your build and your run phase, right? You build your container, then you run those containers. So you have to segregate these two as two different phases of containerization, right? So when you build something, you need a couple of tools to build your containers. For instance, you need Maven to build your container, but when you're running it, you don't necessarily need those build tools, right? So you can just copy your artifacts or your binary into your final image, right? So that your final image is lightweight, right? So this is called a multi-stage build. So you have to segregate. That's why when I introduce you to the containerization process, I talked about run script separately and build script separately, and we have to segregate those two phases, right? And then you can use Docker Slim to check if there are duplicate files and wasted space. And you can also use optimal base images, like what I mentioned earlier. You have to start making the dependency list, and then make sure that the right dependencies are in the right layers. And you can use in some cases you can have slim versions, say Ubuntu slim versions, or you don't have to have the bulky base images. And you can consolidate the run commands and use Docker Squash to combine the layers. So the run commands, this is again a new learning for me. When I was preparing this slide deck, I also experimented a few things, and I learned this. So if you are using multiple run commands, each run command is going to add a new layer of your image. So it's better to consolidate all your scripts and run as one single run command. And if you have Docker Squash to combine layers, say for example, in one layer you added a few files, in the next layer you deleted a few files, then when you squash it, ultimately it creates one layer which does not have those files. So if you don't squash it, then each layer, in the first layer you still have those files, right? So these are some of the best practices. As I said, we don't have all these practices right now, but I also learned this as a part of this process when I was preparing for this session. So I'm happy to share these with you, right? But some common ones which we already use are like Docker ignore, multi-stage builds, and things like that. How do you track the application change? Okay, this is again, it's a question for the community, right? How do you track what commit went into what build, a Docker image, right? So one way is to tag the builds and the Docker images. So you can use the commit ID to tag, but that's again may not be efficient. So you may have to have a separate dashboard that keeps track of what image and what commits, right? So that's another suggestion here. Okay, so this is again, have you lost your application specific data or logs? So if you are maintaining a Jenkins environment, for instance, if you restart it as a container, if you restart it, all your pipeline code is gone, right? So I don't know how many of you have faced this problem. because Jenkins maintains all the pipeline code within a var lib Jenkins by default in a Linux environment. And if you restart it, all your data is gone. So you have to mount those folders as volumes and make sure your hard work is not gone for a waste, right? So you need to kind of keep this in mind. Is your tag Docker image behaves inconsistently? Now, this is also something that we recently faced, and we realized that we use add commands instead of copy commands. So when we do it's not necessary that we have to do it. Even the layers beneath our base images, in our base images, if somewhere add command is there, then it can actually lead to inconsistency. So add uh, can be used to copy certain files from remote location, and if something changes in your remote location, and your layer can change, and if you are building the same code again using your Docker file, and if your base image has somewhere add, it may actually lead to some inconsistencies, and this is something that you need to keep in mind. Okay, so now these are bonus points. So which I think most of us know. When we containerize, we need to keep one process per container because it's easy to scale, easy to monitor, and optimize. Right. So if you club multiple processes together as a container, again, it's you have to. You can't scale them independently. You can't debug them independently. It's very difficult to maintain in a long run, right? And add graceful termination. This is again something that we came across, which is a dump init. Just like I said earlier, so if you do a sick term, it may not kill all your child processes. So if you start your service using your dump init during your run command or script, then it actually spawns the whole process as root user ID1, and if you terminate it, it will terminate all your sub processes as well. So you can go look at it. This is again an open source project. You can go look at dump init. You need to implement vulnerability scans, and you should not run as root user. Even though we talk a lot about this, in my experience, I've seen a lot of developers still used to get running the containers as root users. And when you go to production, you will all of a sudden see that your services have challenges because your IT teams will restrict you from running as root. For instance, we faced a lot of issues when we realized, right, when we use a Bitnami image, it never lets you run as a root user. So it has to be run as a non-root, right? And you will realize that so many challenges come up when you run as a non-root. Your volume amount will have challenges. All those things you have to foresee and start, using non-root right from the day one. And NTP synchronization, this I already mentioned earlier. Like if you have a distributed application, so start looking at it early on. Now, Kubefication is the next process. So here we talked about the service disruption, and I think I talked about some of these best practices early on itself. So you have to turn off auto upgrades. You should not use host volumes. Use clustered persistent volumes. So in the sense, never tie your storage to one node. You have a distributed persistent volume across multiple nodes. Some of best solutions around like OpenEBS storage, those kind of solutions can help. You need to maintain a version matrix, templatized release cycle, right? Be it your application, be it your environment, templatize it, right? So you can just lift it and move it across different environments. If it's your application, you lift the entire template. You sign off as developers, as a release manager, you can sign off the whole template, and then you move that across your different environments. So when you are releasing a template. So template itself acts as a version matrix for you. So okay, this service A build version this, so service B build version this, okay, so your database build version this. So when you templatize it, you are releasing all those together as one single package, and all your configurations as one single package. So that way you can prevent errors happening at the last minute, right? Here is a link that we have written up an article talking about the deployment strategies, how you have to implement your deployment strategies based on your application. So you can go through this link to know more about it. Similarly, you have to set the right scheduling strategy. So we'll go through all of this in the next couple of sessions. So how to set these scheduling strategies, right? And the data laws, again, all these scheduling strategies will be of great help. Overshooting budgets, set the cloud budgets, set automatic alerts, and you can also have granular scale up and scale down limits. So we have implemented something at a granular level for Azure. So you, again, the link will give you more insights into that, because when you are using Azure AKS or something, so it does not by default give you all those granular auto scaling rules. You need to add additional scaling rules like a warm up or a cool down limits and the windows that you can set. So it's not very in the initial phase it's not very obvious, but you have to start implementing it. Now, here are some additional challenges. So, why am I talking so much about the challenges, right? And why am I getting into this depth, right? So, before this is a precursor for you, right? Before you start learning something, you need to know what you're getting into, right? So, I mean, it's exciting for me. I've been using Kubernetes. We have been building stuff on top of Kubernetes. It has been an exciting journey, but at the same time, we also had a lot of frustrations. It's not like it was a smooth path from day one, right? The excitement and these frustrations come hand in hand. So before we get into the exciting part, let's talk about these. We need to know these, right? So let's talk about the automation and control. Now, having deployed to Kubernetes, we have seen all those the implementations on writing YAMLs, Docker files, and everything. But as a team, when we come together and start building the automation, right, we start looking at multiple third-party tools. How do we manage integrations and configurations in one place? Now, this is a question to the community. You have your source control repos. You have um, cloud environments. You have your say for instance, if you're using Slack or PagerDuty, you have your tokens managed somewhere, right? How do you manage this, all these configuration? You have Jenkins pipelines, right? uh, how do you, on your monitoring tools, and your, if you have implemented a EFK stack or a monitoring Prometheus and other monitoring tools, right? How do you manage all these configurations? If something goes wrong, where, where do you go and start? What would be your starting point for looking out for information, right? So how do you manage these integrations, right? It's a question to you. So if somebody has some inputs, please do share it in the chat room, right? Next, how do you collaborate and maintain control across this whole process? So you have a development team, you have an SRE team, you have a DevOps team, and there is a, management team. So how do you kind of collaborate and maintain the access across these different tools and different processes? How do you measure the efficiency of this whole pipeline? In my opinion, I think it is how quickly can you release, how quickly can you identify issues and resolve those issues, right? So for instance, if you have to detect issues, you need to know all these Kubernetes and Docker commands offhand. Like you should know how, okay, tell me which replica is running where. So you need to know whether this replica is the code that is running inside your service is causing an issue, or is it the node that is causing an issue, or it is the disk. So how do you find out, right? So you need to have all those kube commands offhand to find out those information quickly. If you are using all your configurations in Kubernetes, we have these concepts of secrets. So is secret causing an issue? So if you had to go debug, everything is in base 64. Now how do I check? I had to do a converter, and you have a huge set of YAMLs. Let's say for our own platform, we have around 150 plus YAML files. And if something goes wrong, where do we start, right? How do we go look out and debug issues, right? So the mean time to detect issues is still going to be complex. And if you're maintaining parallel releases, the concept of GitOps, right, where you maintain all these artifacts in GitHub. And the suggestion is, if you are having parallel releases or different environments, you will have separate branches for maintaining your YAML files for different environments. Now, how do I manage parallel releases? Now, have a mix and match, like how many, if you have 4 environments and 2 parallel or 3 parallel releases, how do I manage all those YAML files? Where do I manage those YAML files? And if something goes wrong, how do I figure out which release, which branch, which environment, right? So it is complex the moment we start looking at day two. So what is the path to innovation, right? This is again for people, for larger teams who have already in the phase of implementing it. You would have realized that the efficiency and control is the path to innovation. So the efficient we build and efficiently we manage the whole setup is the path to innovation. So how do we achieve these two, right? We need to have a platform, right? A platform that combines all these best practices, the visibility and the automation in place, right? So there are, for larger teams and enterprises, they usually have a platform engineering team who kind of builds a platform that will cater to these efficiency and control requirements, right? And for a smaller team who is just getting started, or who do not intend or to prioritize this to build it in house, then we want to introduce this gopaddle Lite, which is a community edition of gopaddle, which is a self-hosted environment. You can have it on your local desktops, cloud environments, your own AWS, Google, or Azure cloud environments, or in your VMs, and it runs on a microKDS, again, which is an open source version of Kubernetes, right? So absolutely at no cost, and it is a lifetime free community edition, and is intended for learners, beginners, and for larger enterprises who want to quickly start and then do some proof of concepts and implement it and show it to their teams, right? So what capabilities do you get? You can Dockerize, Kubify, everything automated at a very basic level. And if you want to do advanced configurations, it's all simplified. And you get all of the out of the box DevOps automation, like monitoring, alerting, and CI/CD enablers. And you have a couple of marketplace apps that you can subscribe and start using it. And as I pointed out earlier, how do we debug, identify issues? The mean time to detect and resolve those issues is simpler because you have some of these DevOps tools pre-built into the environment, right? So you can find more information about this in our gopaddle repo, gopaddle-io microKDS Kubernetes add-ons -lite. Sorry, it's overridden here, so but you can read it out. So we are going to use this tool in the next couple of sessions. And what we are going to cover is this, right? In today's session, I have introduced you to gopaddle Lite and the whole process of building and deploying to Kubernetes, right? In the next couple of sessions, we are going to talk about bringing up this environment first, because we are going to use this as an enabler to build and deploy. Then we are going to, the next week 3, we are going to start configuring some of the repositories, right? And then onboard the applications to gopaddle. Now, when I say onboard the applications, it is going to Dockerize and it is going to deploy to Kubernetes in one step, right? So you can bring your own applications, your own environments, and we are going to do a hands-on session on this. Next, how do we monitor applications and environments? So what kind of monitoring capabilities we have, what sort of metrics we have, right? What does those metrics mean to us? Then how do we debug issues? And we will also subscribe to, say, Postgres, and then build a larger application, right? And at the end of the week 7, we will have a CI/CD pipeline. We can do this with Azure DevOps, GitHub Actions, and Jenkins. So we have a few templates which we will suggest, and you can go build a CI/CD pipeline for your own application, right? And the last session, we will have a developer connect and use cases. So if any one of you is interested in sharing your end-to-end setup and your automation, you can come and share it with the rest of the community and showcase your deployments and your learning from this session, right? So this whole session is going to be a hands-on session, right? You will bring your own microservice, you will bring your own environment. It can be a VM, it can be your own local desktop, or it could be your own cloud environment. And we will parallelly do live demos, and we will spend 15 minutes together on debugging some of those sessions every single week, right? So we'll make sure that we cross this session every week session together, and then we will make sure that the goal that we have for that session is completed. And then at the end of the week 8, we will have a learners demo session, so where you can get to showcase what you have built so far. So you will have at the end of week 8, you will have a complete dockerization, cubification, automation, end to end, and some of the best practices. As we go along, we will be sharing those best practices as well. Okay, so for this next session, let us start with this. For the time being, the requirements for the system are slightly larger. We are optimizing this, as I said, like we are still optimizing our own build. So our Lite edition runs on microKTS as Kubernetes services. So we need to bring up microKTS and deploy our services. We have around 28 services, so we need that much capacity to run. Okay, so we have all distributed services like RabbitMQ, Inflex, Mongo, and everything. So we need so many services to run, so we need this capacity. And we need an Ubuntu 1804 and microKTS 1.24. If you can install it, you can keep this ready, or else we can also do it during the session. And as a part of this, we'll also install Helm charts. And then we will have to open these firewalls. We can try setting this up prior to joining the next session. You can open up 30,000 to 30,006 and 32,000, which is again 32,000 is for our Grafana dashboard. So you can keep these firewalls open, right? And you can have a public and a static IP. If you are setting this up on, suppose you are bringing a VM from AWS, you can have a public or a static IP for that instance. Now, what if you are running this whole thing in your local desktop? Not to worry, you will have only a few capabilities cannot be used. For instance, your CI/CD cannot be used in that case, right? In the sense, like, you cannot build a pipeline, but the remaining capabilities are still there, right? In case if you are planning to do a CI/CD as well, if it is a completely a private infrastructure, then like small scale desktop is fine. But if it's a private infrastructure, say you have a VM within your firewall, then you have to have your source control repositories also installed privately. You need to have access from the gopaddle installation to your private repo, and the vice versa, for your continuous integration to work. So it is not a limitation of gopaddle, but it is a limitation of how these webhooks and others work. So this is the requirement that we have before we join the next session. So I'm going to end with this. Any questions or any thoughts on this, please feel free to ask in the chat room, please. Okay. So I think that's all for the timing. I don't see any questions. Thanks so much for joining in. We really look forward to meeting you in the next session, and then we really want to help you with this whole process. Thanks so much for joining in again. And as I requested, you can use our hashtags for any comments or feedback, or if you really want to appreciate our work, you can tag us at gopaddle.io. Thank you. Have a good day.